everyone, and welcome to Geometry Section 2.6, Properties of Equality and Congruence. In this lesson, we're going to be reviewing, or for many of us learning, some of the basic properties that we use in problem solving. First, let's work through this problem. I know it's algebra, but it might help you understand what these properties are. So we have the equation 3x minus 17 equals negative 2x plus 18. To solve it, we want to start by getting the like terms together. We'll start by adding 2x to both sides. Then we're left with 5x minus 17 equals 18. Negative 17 and 18 are like terms, so we'll add 17 to both sides to cancel the negative 17 and get 5x by itself. Then we have 5x equals 35. Finally, dividing by 5 on both sides leaves us with x equals 7. Hopefully, most of you are pretty comfortable solving equations like that. But have you ever wondered why we take those steps? Why do we say we're adding 2x to both sides or cancel out the 17? It all comes from the properties of equality. Properties are a lot like theorems. They're rules or statements that define relationships in math. We'll look at some of the basic properties of equality today and also check to see which ones carry over into congruence, which is kind of like equality for shapes. Our first three properties of equality all carry over into congruence. First, we have the reflexive property. The reflexive property tells us that a number is equal to itself, so 3 equals 3. They have the same value. The numbers always have the same value. In congruence, this property tells us that every figure is congruent to itself. While we don't really work with the reflexive property a lot in algebra, it's one of the more common properties that you'll be using in geometry. We see the reflexive property anytime we have two figures that overlap. Next is the symmetric property. This one's really useful for reordering statements. An example of the symmetric property would be to say, if AB equals 2, then 2 equals AB. If the length of segment AB is 2, then 2 is the length of segment AB. Seems pretty obvious, and I'm sure you've used this property without even knowing it. The same is true then for congruence. If segment AB is congruent to segment BC, then segment BC is congruent to segment AB. This property helps us to set things up for the next property. My favorite property of equality is the transitive property. The transitive property helps us link statements together to make new ones. In this example, if AB equals BC and BC equals CD, then AB equals CD. It links the beginning of the first equation with the end of the second equation. This property is a lot like substitution, but the important difference is in the ordering. Your statements have to line up just like this, with the middle terms being the same, and then the beginning and end make up the new question. It's a lot like the law of syllogism, really. If you think about it, the transitive property is really neat. Let's think about this in terms of friends. Let's say Anna is friends with Ben, and Ben is friends with Cameron. By the transitive property, Anna would have to be friends with Cameron. Think about this situation with some of your friends. Does the transitive property always work with friendships? Maybe, but for most of you, you can probably think of a situation where this wouldn't work. In math, though, the transitive property always works. There are lots of friends in math. Part of what we'll be doing in this section is identifying which property justifies a statement. To do that, you want to know what features will help us differentiate between the properties. First, if the statement has equal signs, it's a property of equality. If there are congruent symbols, we're looking for a property of congruence. Then we can start looking for keywords. The symmetric property has the words if and then. The transitive property has the words if, and then. The reflexive property has nothing other than the one thing equal or congruent to itself. Try to remember those key words for later on in the lesson. Next, let's look at the 5 properties of equality. These 5 are used anytime we solve an algebraic equation. They make up the basic steps we're used to using. These don't carry over to congruence, but only because it doesn't really make sense to combine the actual figures with mathematical values. First is the addition property. The addition property of equality says that adding the same number to both sides of the equation will not change the result or solution. We use this property to solve the equation x minus 3 equals 7. Adding 3 to both sides, which actually looks like this, leaves us with x equals 10, our solution. Next, let's look at the multiplication property of equality. This property tells us that multiplying both sides of the equation by the same number will not change the result. In the equation x divided by 5 equals 6, we multiply both sides by 5 to get x equals 30. Now let's check out the subtraction property of equality, which maybe you guessed says that subtracting the same number from both sides of the equation will not change the result. In solving x plus 8 equals 12, subtracting 8 from both sides leaves us with x equals 4. Our last operation is division, and it also has its own property of equality. Just like the others, dividing both sides of the equation by the same number doesn't change the result. So in 4x equals 12, we can divide both sides by 4 to get x equals 3. We're out of operations, but don't worry, there's still one more property. I knew you'd be disappointed if you only got 7 properties, so I threw in one more just to get us up to 8. The last property of equality that we'll talk about today is the substitution property. This property basically gives us permission to replace parts of an equation with something that has the same value. For example, if we know that x equals 3, then the expression 4x minus 12 equals, or has the same value as, 4 times 3 minus 12. Since x and 3 have the same value, we can just exchange them. So when x equals 3, 4x minus 12 equals 0. That's all of our properties for today. Now let's see if you can put them to use. We'll start off with some easy ones just to get you going. Let's start by looking at some statements and choosing the property that they illustrate. Our first statement, if segment ST is congruent to segment UV and UV is congruent to segment YZ, then segment ST is congruent to segment YZ. We're looking for a property of congruence from those congruent symbols, and we have the keywords if, and then. This is the transitive property of congruence, which we can abbreviate like this. Next, we have the statement, if FG equals HJ, then HJ equals FG. Notice that here the italicized notation for those segments means we're talking about the numerical lengths of those segments. We have an equal sign, so this will be a property of equality. Our keywords are if and then. This is the symmetric property of equality. Our last example, we have angle C congruent to angle C, and it's showing that something is congruent to itself, so this is the reflexive property of congruence. Now let's see these properties in action. We're going to try solving a couple equations, but for a little extra fun, we'll justify each step along the way with one of the properties we've just reviewed. For our first attempt, we're going to try and solve and justify 3 times the quantity x minus 2 equals 4 times the quantity x plus 7. In this problem, we need to start by distributing the 3 and the 4 to get rid of the parentheses. That leaves us with 3x minus 6 equals 4x plus 28, and that was the distributive property. Next, let's combine all of our x terms. We'll subtract 3x from both sides. That's the subtraction property of equality. Then we're left with negative 6 equals x plus 28, and we'll say that was the definition of subtraction. Our next step is going to be to combine those two constant terms, so I'll subtract 28 from both sides, and again that's the subtraction property of equality. That leaves me on the left side with negative 34 and on the right side with just x. So I could be done here and say that that's the definition of subtraction, or I could get a little extra practice with my symmetric property and make it look really cool and change that order around to say x equals negative 34. And again, that'd be the symmetric property of equality. That last step isn't necessary, but if you want a little extra practice using some other properties, it might be fun to throw in there. Let's try one more before we're done. Now our equation is 3x plus 17 equals 5x plus 13. Start by subtracting 3x from both sides, the subtraction property of equality. Then we have 17 equals 2x plus 13. That's the definition of subtraction. Now combine constants by subtracting 13 from each side. Definition of subtraction again. Subtraction property of equality again. And then the definition of subtraction. We're kind of wearing these out today. Then after using the definition of subtraction, we'll have just 4 equals 2x. Our last step is to divide by 2 on each side. Finally, something different, the division property of equality. Then when we use the definition of division, we get our answer 2 equals x. And again, you can practice the symmetric property of equality if you want to, and your answer would read x equals 2. It takes quite a bit more time and effort to make note of every property that you're using along the way, but it's important to realize that someone somewhere has justified every step you take to solve these problems. You're following the rules of math and you probably didn't even know it. Thanks for joining me, and happy hypothesizing.